is from x equal to 0 to x equal to 2. Now, first of all, we need to revolve the area enclosed by y equal to square root of 4 minus x squared. The function is a function of x, and we revolve it about the x-axis. Alright, the first thing to do is to draw a diagram. So, draw the graph of f of x equal to square root of 4 minus x squared. Can you tell me what is actually the graph of square root 4 minus x squared? You should be able to tell me without even graphing it. If you can picture x squared plus y squared equal to 4, what does that equation represent? X squared plus y squared equal to 4. It's a circle of radius 2. If you solve that equation for y, you get y equal to plus or minus square root 4 minus x squared. The plus is for the upper part of the circle, the minus for the lower part, isn't it? So this is the upper part of a circle of radius 2. So when you graph it, you should be able to, well, my diagram did not come quite as a circle, but actually it should be a circle. So this is the graph of y equal to square root of 4 minus x squared, or f of x equal to square root of 4 minus x squared. And this is x equal to 0, this is x equal to 2. That's right, the radius of that circle is 2. Now, what's the first step? Take a strip of area dA of width dx at right angles to the x-axis. So we come here and take a strip of area called dA, and its width is dx. Alright? The width of this area is dx, the length of that area is f of x. And what's the second step? The radius of revolution, when this is revolved about the x-axis, the disk generated will have this radius, and that radius equal to f of x equal to square root of 4 minus x squared. So the radius of the disk generated, r of x, we now know. Alright, so that's the radius, r of x equal to square root of 4 minus x squared. The third step, find the volume of the disk generated when this area is revolved. What is the volume of the disk generated? The volume will be pi r squared dx, where r is the radius of the disk, which is this length, which is f of x. So dv equal to pi r of x squared dx. R of x is the radius, and that radius is equal to this. So we replace r of x by this quantity. So that will be dv equal to pi times the square of the given function dx. And the square of a square root quantity will remove that square root. So that will be pi times 4 minus x squared dx. Alright? This is dv. Now what all we need to do is integrate that from x equal to 0 to x equal to 2 to find the total volume of the solid generated. So find the total volume by integrating dv from x equal to 0 to x equal to 2. And you get v equal to integral 0 to 2 of dv, where dv is this. Alright, can you integrate this? What is integral of 4 dx? Well, pi is a constant, I will stay outside. So integral 4 dx is 4x minus, what is integral x squared dx? It is x cubed over 3. Alright, so that will be pi times integral 4 dx is 4x minus integral x squared dx is x cubed over 3. So we integrated. Once you finish integration, put that with the limits shown like this. The lower limit is 0, the upper limit is 2. What's the next step? Find the value of this by replacing x by the upper limit, then minus replace the x by the lower limit. Because the lower limit is 0 and each term contains x, the value of the lower limit will be 0. So you don't need to worry about it. You need only replace x by the upper limit. Is that right? So that will be pi times 4 times 2 minus 2 cubed over 3. That's the upper limit. Minus the lower limit is 0. And that will be pi times 8 minus 8 over 3. And what's that equal to? What is 8 minus 8 over 3? 16 over 3. So that will be 16 pi over 3 is the answer. Now, can you tell me, what is that solid that you generated here? Now, we talked about that y equal to square root of 4 minus x squared is actually y equal to square root of 4 minus x squared is actually the top part of the circle. Now, we didn't take all of that top part. We only revolved the area from x equal to 0 to x equal to 2. That means what you are generating is a half of a sphere. If you revolve the whole of the area above the x-axis, that is a semicircle, if you revolve that, the whole of that, you will generate a sphere of radius 2 centimeters. But we are only using half of that. So what we are generating is half of a sphere, or you call it a semicircle, a semisphere. Well, what is the equation for the volume of a sphere? You can actually use this method to find an equation for the volume of a sphere. The volume of a sphere is 4/3 pi r cubed. Is that right? Now, the radius in this case is 2. So 4/3 pi r cubed. R cubed is 2 cubed, that is 8. What is 4/3 pi times 8? Is 32 pi over 3. So 32 pi over 3 is the total volume of the sphere. This is half of that, because what we have generated is a half of a sphere. Okay. Now, let's try another one. Find the volume generated when the graph of y equal to 4 minus x squared on 0 to revolved about the y-axis. So before, just now we revolved that area about the x-axis. Let's now revolve that area about the y-axis. Well, first draw the graph of f of x equal to that and shade the area enclosed with the, well, we need to do it with the y-axis, is that right? Yes. And if you remember what I told you, in order to revolve an area about the y-axis, you first of all need to express the function as a function of y. So here the given function is a function of x. You get y equal to square root of 4 minus x squared. You need to write it as x equal to square root of something. Now, how do you do that? What all you need to do is now this is y equal to square root 4 minus x squared. Now take that function and solve it for x so that you can write it as x equal to something. Now, how do you do that? Y equal to square root 4 minus x squared. Can you solve this for x? Very simple. Square both sides. Gives me y squared equal to 4 minus x squared. Now solve for x squared. It gives me x squared equal to 4 minus y squared, or x equal to plus or minus square root 4 minus y squared. Now, I want you to appreciate these kind of expressions. You see, the expression that we started with, y equal to square root 4 minus x squared, is a circle above the x-axis. Y equal to negative square root 4 minus x squared is below the x-axis. Now the positive and the negative together gives you the whole circle, x squared plus y squared equal to 4. In the same way, x equal to positive square root 4 minus y squared gives you the positive part, the right side of the circle. And negative square root 4 minus y squared gives you the negative part, and the two together will give you the complete circle. So here we actually need only the positive part because it's on the right side. So we only use the positive part of this. Okay, so we have now f of y equal to square root of 4 minus y squared, which is also the same as x equal to square root 4 minus y squared. So we have done that. What's the next step? Take a strip of area dA at right angles to the y-axis. There you go. Now, the width of that area is dy, and what is the length of that strip? The length of that strip is f of y. Okay. The position of the strip can change from, the position where you take the strip can change from y equal to 0 to y equal to 2. Yes. You see? This is y equal to 2. This is x equal to 2. Now, how do you know this is y equal to 2? Now, remember, this corresponds to the value of y when x equal to 0. The value of y when x equal to 0, when x equal to 0, y squared equal to 4, or y equal to positive 2 or negative 2. We only take the positive. So we have the position of the strip can change from x equal to 0, no, y equal to 0 to y equal to 2. There you go. Now the length of this dA is r of y equal to fy, and which is square root of 4 minus y squared minus 0. Of course, this is your x equal to 0. X equal to square root 4 minus y squared minus x equal to 0. There's no need for that at this time. Second step, the radius of the disk generated is the length of the strip that we have identified already. Now, what is the volume generated when this dA is revolved about the y-axis? It will be dV equal to pi ry all squared dy, and that ry equal to this quantity, equal to this quantity. So that will be 4 times the square of this will be 4 minus y squared dy. And now find the total volume by integrating this dV from y equal to 0 to y equal to 2. So you got the total volume V equal to pi times integral 0 to 2 of 4 minus y squared dy. And this can be integrated easily. What is the integral of 4 dy? Which is 4y minus integral y squared dy is y cubed over 3. So that will be pi times 4y minus y cubed over 3, where y goes from 0 to 2. Now let's evaluate this for the upper limit minus the lower limit. Again, the lower limit will yield just 0, because when you replace y by 0, both these will become 0. So we need only take the upper limit. So that will be pi times 8 minus 8 over 3. That is 16 over 3, the same thing as we did earlier. So this will be 16 pi over 3. Now, The question I actually answered already, but I want you to think about it again.